All right, problem number 44 in the pre-calc review. How many different pizzas can be made using toppings from a list of 8 available toppings? All right, so in this case, order doesn't matter. And since order doesn't matter at all, we are dealing with a situation of combination. All right, now, that means that we have a total of 8 toppings, 8 combinations of 3. All right, now, in that case, all right, if we do that quickly in the calculator, clear, 8 math probability down to combinations of 3, it gives us 56 combinations. All right, if we happen to use the formula for combinations, and all right, we say what? 8 factorial over 3 factorial times 8 minus 3 factorial. All right, and so that's 8 factorial over 3 factorial, 5 factorial. All right, now the 8 and the 5, remember, that'll leave us with 8 times 7 times 6 over 3 times 2. All right, the 3 times 2 is coming from here. The 8, 7, and 6 is what's left over after we cancel the 5 factorial. All right, that's 8 times 7 times 6 over 6, where the 6 would cancel, and it's just 8 times 7, which is 56. All right. Problem number 45. How many different ways are there to arrange 5 photographs on a shelf? All right. So order matters. All right. So this is would be sort of a permutation of 5 in 5 spots. So you could say 5 permutations of 5. All right, regardless of which way you do it, and I know we did it earlier using just 5 spots, and we said, well, if you put, how many choices do you have here? You had 5, and if you put 1 there, then you had 4, and you put 1 there, you had 3 and 2, and then only 1 left over. All right, the way to do it with permutations, all right, because permutation is n factorial over n minus r factorial. All right, and so if that's the case, we have what? 5 factorial over 5 minus 5 factorial. All right, now that gives us 0 factorial. And 0 factorial, please note that 0 factorial is always going to be equal to 1. All right, so that still just leaves us with 5 factorial, which is 120 ways. All right, let's keep it moving. All right, represent the series. Represent the series using summation notation. All right, so this is how we've been doing this. We're trying to figure out the pattern first, of course. All right, figuring out the pattern here is, looks like a times 2, times 2, times 2. All right, it goes on to infinity. All right, so let's see if we can get this. All right, we go, since it is times 2, what we have is a geometric series. All right, it's geometric, and when it's geometric, we use an is equal to a1 times r to the n minus 1. All right, so we have the summation. All right, we start at n is equal to 1. All right, a1, the first value is 8. the r value, which is how much we're multiplying by, r is equal to 2 times 2 to the n minus 1. And since it's going to infinity, we put, it doesn't stop, we put the infinity sign. All right, that's one way of doing that. All right, and that pretty much works for us. Now, you'll notice that the answer in the semester exam review is this. 2 to the n plus 2. But their method of teaching it is a little different. We're going to go with what works for us. These two are equivalent answers. All right, any questions? You can't ask questions right now. All right, let's keep going. 11, 15, 19, 23, 24. It's increasing. What's going on? And it also is finite, meaning it stops. All right, so what's going on here? Let's see. It looks like I'm going plus 4 every time. All right, so what we have here is a arithmetic series, all right, where we're increasing by 4 every time. Now, this is how we did it. Now, we started with our sigma. We started with n is equal to 1. Whatever our common difference is, all right, we made that 4. Common difference is 4, so we went 4n, all right, and then we plugged the 1 in to here. So we're saying 4 times 1 plus what will give us the first term, what will give us 11, all right, and so we see that that value is 7, all right, so since that value is 7, we add a 7. Nothing too complicated, all right, and then we want to be able to figure out this last term, so we have to figure out what goes here. We go 4n plus 7 is equal to 35. Subtract 7, we go 4n is equal to, what's that, 28? Divide both sides by 4, and n is equal to 7. Now, we did that this case, all right? I showed all this because depending on the example, all the values won't be there. But we could easily say, well, this is the first, second, third, fourth, fifth, sixth, seventh value, and write our 7 there. Either way works, but this is the process we use when you don't know what number that is in the series. All right, 49, 50, and 51. All right, let me freshen these up. Not sure what number that is. Oh, that's an infinity. All right, so let's go through these. Determine the sum, if any, for the infinite series. All right, so we said for these, all right, all of these are geometric, and our rule is that the absolute value of our r, our common ratio, all right, our common ratio, all right, must be between 0 and 1 for a sum to exist. Just for the sum to exist. Now, if the sum exists, then your sum is equal to a1 over 1 minus r. All right, so using that information, let's look and see what's going on here. All right, times, oh, and this was missing on the key. On the semester exam review, so you had to put the 1 in there. All right, looks like we're going times 1/3 times 1/3, all right, every time. So your r value for this problem, we change your r value for this problem is 1/3, which is between 0 and 1. So the sum does exist, all right? Since the sum exists, your sum is going to be your first term over 1 minus 1/3. That gives us 9 over 2/3. All right, And that right there is equal to, let's say, 9 over 1 times 3 halves. I don't know how you guys do that, but that's how I do it. All right, 27 over 2, which is what? 13.5? 13.5. All right, how we doing? Hope we're okay. That was my 49. Yes. All right, so now let's look at the next one. Now, a lot of people had questions with these, even on the packet. All right. But an easy way to do it is just to do a couple of values out, all right? If I put the 1 in, I get 3 times 2 to the first, which is equal to 6, plus 3 times 2, all right? 2 squared gives me 4, times 3 gives me 12. All right, I'll do one more and you can see what's going on. You should already be able to know, you should already know that this value is your R, but just in case you don't know, let's go again. 3 times 2 cubed. 2 cubed is 8. 8 times 3 is 24. So you can see what's going on. Dot, dot, dot. Now, times 2. Times 2. All right, so R is equal to 2. Like we said in the beginning, some people should be able to notice that that's your R value. Now, is R the absolute value of R between 0 and 1? No. So R is equal to 2. Therefore, the sum does not exist. All right, D and E, done. All right, like that problem. All right, once again, if it's set up like this, this is your R value. So R is equal to 3/4. Now, if I didn't know that, and I'm having a problem with that, then I'm going to do a couple of values out for number 51. All right, I can go 8 times 3/4 to the first. That's going to give me, what, 24/4, and 24/4 is 6, plus 8 times 3/4 square. All right, that's going to give me 8 times 9/16. All right, and that's going to give me, let's see, 72. Well, I can go 8 over 16 is 1/2. So this is 9/2. All right, and then again, 8 times 3/4 cubed, which is 8. 27 over 64. All right, remember, we're cubing and cubing there. All right, in that case, this is 27/8. All right, I feel like I just wasted some time. All right, because every time I'm multiplying by 3/4. All right, you can look at the numbers. If this is 6 over 1, multiply that, 3/4, keep on going. All right, now, does the sum exist? How do I know? I take my 3/4. Well, let's see. 3/4 is between 0 and 1, so the sum does exist. Now, once the sum exists, we got some work to do. The sum is equal to the first term in the sequence. What was the first term in the sequence? 6. So we had to do that. 6 over 1 minus 3/4. All right, now finishing this up, this is 6 over, what's 1 minus 3/4? A fourth. All right, that's going to give us 6 times 4 over 1. All right, and that is 24, a sum of 24. All right, keep it moving right along. All right, I'm going to change the board the long way. Wanted to get more problems in. I was running out of boards. See if we can make this a little bit bigger. Oh, there. All right, so let's see what we can do. All right, for 52, 53, and 54, they are asking for us to evaluate. All right, and you see that the first two are or 52 and 53, they're asking us to evaluate. All right, so these aren't bad at all. I think we can pretty much take care of these pretty quickly. All right, you're plugging 1 in, 2 in, 3 in, you stop at 4, all right, into the function and adding the numbers. So we have 3 times 1 plus 1, all right, which is 4, plus 3 times 2 plus 1, that's equal to 7. Plus 3 times 3 plus 1 is 10. All right, you can kind of see what's going on, right? 4, 7, 10. What's the next value? 13. All right, you want to check it? All right, 3 times 4 plus 1. All right, that's giving us 13. All right, so then we just add these values up. That plus that will give me 20, plus 10 would give me 30, so the answer should be 34. All right, and as I go along, I'm checking the answers too. All right, next problem. All right, 4n, we're starting at 5. All right, if we're going to start at 5, then that's 4 times 5 plus 4 times 6 plus 4 times 7 plus 4 times 8, plus 4 times 9, and we stop at 4 times 10. So that's 20 plus 24 plus 28 plus 32 plus 36 plus 40. All right, and adding that up, well, I'm pretty sure you're going to use a calculator. All right, but that's 60. That right there is 60. And that right there. All right, so we got 60, and then you got 60, and you got 60. So what is that? 180? And that's what it looks like, 180. All right, any questions? Hope not. All right, our favorite problem. This is where we use the triangle. All right, and hopefully some people really need to listen to this one. All right, but that will be up to you. You gotta do it, right? All right, so this is number 54, I think. Is this the last one? I hope so. Nope, we got one more page of problems after this, 54. All right, so it says expand. All right, now it's the 4th, so we need our 4th level of our Pascal's triangle. While I'm talking, I'm just going to do Pascal's triangle here. 1, 3, 3, 1. Yes, there is a way you can get this in a calculator. Most people show that. I've been doing this all by hand, so why stop now? All right, it took a second while I'm talking. All right, there is the 4th degree of Pascal's triangle. This is what we will start every problem, start the 4th degree with. All right, so I have 1, 4, 6, 4, 1. All right, let's see. My first term in this expansion is x. Our second term is -2. So we're going to use these numbers. We're going to go 1, using the 1. All right, using the x. Let's use a different color. 1 again from here. X to the degree. Starting degree is 4. X to the 4th. All right, we're going to go 4. Just going to put a plus 4. X. I'm going to put a plus close for the first one, and I'll show you in a second why. All right, we're going to go 4. X cubed. Just leave some space. 6. X. All right. we're going to go, well, let's put the -2 here. Hold that space. Put the -2 here. Alright, plus 4x to the first. And then we're going to hold the -2 plus 1x to the 0, which we didn't really have to write. Alright, so we got 4, 3, 2, 1, 0, and the -2. Alright, and then in the opposite direction, we have 4, 3, 2, 1, hey, 0. That's why I didn't write it. Alright, now, simplify each term. Alright, this ends up being x to the 4 plus, this is 4x cubed times -2. And yes, we're going to have to go another line now. Plus 6x squared. Now, -2 squared is a positive 4. Plus 4x to the times -8. Plus, that gets canceled, and it's just -2 to the 4th power. That's 2, 4, 8, 16. Alright, so last line. X to the 4th. This minus 8x cubed. This is 24x squared. This, what's next? I put a plus, it should be a minus 32x plus 16. And we are done with number 54. Alright. And let's finish up. Alright. What is the coefficient of the x cubed in the expansion of x plus 2 to the 5th? So, once again, while I kind of set this up, I like these problems. You should, because unlike the first videos we did, or I did in class, you don't have to write out all the terms, but you do need 5th of the Pascal's triangle. To me, Pascal's, I mean, you do it a couple times, and it should take a second. And if you're in your final, you should just do it once on like a scratch sheet of paper, just to so you don't, you'll have it in front of you. It'd be a good idea. Or you can wait till you get to the problem. You may not even have a problem where you have to do it long. But I'm pretty sure in the last few years, this problem has always been on the test. All right. So it says, what is the coefficient of the x cubed term? Now, if you think about the 5th degree, all right, this, since the x is the first term, we usually go, what? X to the 5th, x to the 4th, x to the 3rd. So it's going to be this term right here, all right? Now, knowing that, I'm going to go 10, pulling that 10, x, now 5, 4, 3, and 2, 5, 4, 3, 2. Alright? So that's a square. Now, go ahead and do all that. We got 10 x cubed times 4, which means this is 40 x cubed, and the answer to the question is 40. Alright. Now that I erased this last problem, what is, this is a similar problem but a little bit more difficult, the coefficient of the x to the 9th y term. That's what it should say. Alright, in the expansion of x cubed plus 5y to the 4th. Alright, so once again, let's take that line. We got 1, 4, 6, 4, 1. Now, This is a little complicated. I would hate to have you have to do this one on the final where you have to do it all, but you don't. All right. We just got to figure out this cube and this x to the ninth. How would we get x cubed and x to the ninth? All right. And so, since it's 4 terms, it would be this to the 4th. You would have x. If it was the first term, it would be x cubed to the 4th, which would be x to the 12th. All right. If it was this term, it would be x cubed to cube. All right, because we go 4, 3, 2, 1, 0. And this one gives you x to the ninth. And that's what we're looking for. So it's going to be this term. All right. So we can go 4 times x cubed times 5y to the 4, 3, 2, 1. All right, so that's our term. So let's do the work for it. 4, power of a power gets multiplied times 5y. All right, 4 times 5 is 20, x to the ninth y. So for this problem, your coefficient is 20, because that's what they want, the coefficient. All right, and I think that concludes the problems for this section. Good luck in studying.